In this problem, we have a collar, A, which moves at a constant speed. Determine the speed of collar B as a function of position and velocity of A and the distance h. All right, so there are no numbers in this problem. I know that freaks a lot of people out, but we know the numbers. We just are keeping the variables. So we know the speed at which A moves, and we know the position and velocity of A and the distance h. So we want to write our results in terms of those variables. Then once we get numbers, we can plug them in. It's always good to solve problems in the variable form first. All right, so we want to get the speed of B in terms of all those variables. So we can see in this problem, if A moves to the right, B is definitely going to move up. All right, so in a dependent motion problem, which this is, we want to identify the necessary datums. And in this problem, since A is moving to the right and B is moving up, there's two distinct directions of motion, so there'll be two datums. So I'm going to use this rod here as my first datum and measure the position of A relative to that. And then this rod here for another datum and measure the position of B relative to that. All right, so those are the only two things that are moving. And we have one rope, so we can use those two positions and h to determine the length of the rope relative to, or in terms of the position, which is the position coordinate equation. Once we have that, we take the derivative and can relate the velocities. All right. So the position coordinate equation, if we look at the total length of the rope, it's going to be equal to this length, L1, plus this length, L2. And if you think in terms of triangles, right triangles, where we have the two sides and the hypotenuse, we can use Pythagorean's theorem to determine the length of the hypotenuse in terms of the two legs. So the first length would be h squared plus sa squared square root. Second one, sb squared plus sa squared square root. All right, so that's the length of the rope. Now we need to take the derivative of that length. The length of the rope does not change, so that derivative is 0. So we're going to take the derivative of the length equation. Now when I take derivatives, I don't like to keep the square roots, so I'm going to change the square roots into half powers. It's much easier. And then when you take the derivative, you can just use the powers to do that. Now it's a little complex, but if you go step by step, you can see what's going on. So this first term, we're going to take the derivative of the outside, which is 1/2, and then the inside, right? And then we have the minus 1/2. So that's just like taking the derivative of x to the 1/2, right? And then we take the derivative of the inside, which would be 2s times s dot. So derivative of the outside times the derivative of the inside, the chain rule. We do the same for the second term. All right, so once we have that, then we can just use some algebra, rearrange it, and solve for the speed of B. But you notice that the speed of B, we want in terms of the position of A, the velocity of A, and h, but we don't know the position of B. All right, so we need to solve for that. And if we go back to the length equation, we can just rearrange and solve for the position of B in terms of the things that we know. All right, and then we just plug that back into there. All right, so the only thing that really is complex about this problem is taking the derivative. So please look over how the derivative was obtained and make sure you understand all the steps.